Well, yeah, actually, just on behalf of Berk in general, I wanted to say, yeah, a very warm welcome to everyone. For those who don't know, Berkeley Energy and Resources Collaborative is the largest, I think, energy and resources group in the US at the university level. And also very exciting news, later this week, Thursday and Friday, we'll be holding our fall flagship event, the Energy and Resources, the Resources Symposium, rather. This year's event will be focused on the food, energy, water nexus. So if anyone's interested, I just threw the link in the chat. It's a donation-based model, so it's a minimum of $1, but feel free to contribute whatever you'd like. If you'd like to see, we've got our agenda up on our website right now. But with that said, I'm very excited to switch gears to another topic very near and dear to a lot of our hearts here at Berkeley. So this event will be focused on nuclear challenges and perspectives from several really incredible speakers tonight. So I'm gonna, I think, let Rachel kick it off as the moderator, but I think each person will be able to give an introduction as well.
Yeah, so I'm Rachel Slaybaugh. I'm a professor in the nuclear engineering department here on campus. And I've been sort of participating in one way or another with BERC for a long time. It's a great organization. And from when I was in grad school, I still have friends who were in BERC back then. So I'm going to spend a few minutes just kind of setting the stage and giving some overview comments about nuclear. And I'm going to try to keep that fairly brief so that we can actually hear from our panelists and have time for Q&A. But to just give a sense, so nuclear in the United States is sort of a best of times, worst of times story. A lot of the existing fleet is financially challenged. It depends on what market it is and what the finance structure is and what the regulatory structure is. But some plants are shutting down before their licensed times because they can't financially compete basically mostly with low-cost natural gas and the combination sometimes of low-cost natural gas and very low-cost renewables. Other plants in different parts of the country are actually making a bunch of money and are doing really well. So it just depends very much in the United States on what the market is. Globally, some countries are building nuclear reactors. There are many under construction around the world. There are some newcomer countries. Some countries are using nuclear as a decarbonization strategy. Other countries, mostly in Western Europe, are not as sure if they're keeping their nuclear or their new builds are going very slowly. In terms of new builds, there are two sort of bins of reactors that I'm going to talk about. One is large light water reactors. And when I say light water, I mean water, and we won't get into distinctions about that, but those are the kinds of reactors we have most places in the world. They're about 1 gigawatt. And the second bin is advanced reactors, and those are either small and modular, or they use some kind of coolant besides water. We are building 2 new large light water reactors in the United States, and that is very over budget and it is very expensive, and that is the same story in developed countries or in Western Europe. All of the economies that are having a hard time building large reactors are very bad at building large things. Writ large, nuclear is not an exception. We're very bad at building large things. Economies that are building reactors very effectively are usually effective at building large things. So China, Korea, the Middle East is actually doing really well. So that's kind of what nuclear is doing. We also have this innovative advanced reactor sector. So there are startup companies in the nuclear energy space, maybe 50-ish that are really working on nuclear fission. And they are trying to solve different types of problems with different technical solutions. And the people on this panel are working on some of those. And it's really tackling waste, looking at very enhanced safety features, looking at the ability to provide high temperature heat for deep decarbonization, things like this. So some of the things that we worry about in nuclear are financing. How do we make sure that we actually can design and build technologies that are economically viable? And some of that might be making small modular reactors that can be factory manufactured so you can have a different business model. We also worry about waste management and whether our reactors can burn the fuel more deeply to begin with, so we produce less waste and use the fuel more efficiently, whether we have a recycling system. Sam is going to talk about different ways to dispose of the waste at the end. And we look at very strong safety features. Even though reactors are currently very, very safe, they still have a potential for accidents. And so there's the hypothesis that if there's just no chance for offsite consequences, that might be simpler. It might lead to lower costs. It might lead to better public acceptance. Why do we care about all of this? It's because nuclear is an existing large-scale, I was going to say baseload, but we're trying to stop saying baseload, firm electricity resource. So when you're looking at how do we decarbonize, nuclear is something that you can use to complement renewables. And if you look at almost every study, they will show that you can get pretty far with renewables, but to get 100% decarbonized in the electricity sector, you can do that much more effectively if you have a nuclear energy, if you have a firm resource. Nuclear is one of them. You can also do geothermal or solar thermal, but geothermal and solar thermal don't work in all locations. So nuclear is a really important option to get you past when you get to the point of needing seasonal scale storage. You just it's too much. And it can also provide really high temperature heat that can be used for industrial processes to help decarbonize the industrial sector. So it's an exciting time because we're really thinking about and taking on climate in a new way. There are a bunch of startup companies who are doing really different kinds of technologies. We're using new policy tools like zero emissions credits and including nuclear in the term clean, so we can have clean portfolio standards instead of just renewable portfolio standards. So it's really an interesting time. And there are a bunch of government initiatives that are all sort of trying to move the ball forward in different ways. We have some money coming from the private sector. And I think that's where I will stop on the summary, and I'll leave it to the panelists to keep going. Do I have an order? What order would you like them to go in? Because that is not in my notes.
I guess any order. We can start with a little introduction of each panelist. Let's go with Sam, then Lenka, and then Per. How about this order?
That sounds great.
Should I get started then?
Yes, Sam, please, and I'll let you all introduce yourselves.
Okay, I was like, I can either introduce or you can. Perfect. So, hi y'all. My name is Sam Brinton. I use they and them as my pronouns. I am the Director of Legislative Affairs for Deep Isolation, one of the first and probably one of the only nuclear waste startup companies. I come to this work with a super passion for nuclear waste. Many of the panelists on here and many of you who I've met before know that I like to say that I eat, sleep, breathe nuclear waste, which you should never do any of those things, but it is my highest passion. If you sit next to me on an airplane, you're gonna learn about nuclear waste and how cool it is and how we can solve a lot of the world's problems by solving the nuclear waste problem. So I'm going to try to give, they gave me 5 minutes, so I don't probably need all of that because I think it's a pretty simple topic with a pretty simple set of solutions, but I'm gonna give us a little bit of background of what is nuclear waste, what are some of the options for us to do with it, and what are the innovations that we can make on those options. First off, what is nuclear waste? You've heard about it before. When I said the word nuclear, many of you who may not be from the nuclear field thought of one of two things, Homer Simpson or nuclear weapon blast. Those are usually the first two things that people think about. Homer Simpson, you thought about nuclear waste, and you probably thought about that green goo coming out of a barrel. Well, although that was based on some very big environmental problems that the Department of Energy used to have, nuclear waste doesn't actually look like a green goo in a barrel that turns your fish into three-eyed fish. In fact, nuclear waste is generally just long rods of metal. Now, those long rods of metal have to be put somewhere to keep them safe and to keep you safe from them. That's pretty simple. Most of the time that's done in water because water is a really good way of keeping, that like light water. Water is really good at keeping radiation from hurting us. But let's say after a while, you don't need as much water, you can generally put it in what are called dry casks. They basically look like large Pringle cans of concrete. Yes, I'm making this simplified because I'm really tired of us all being scared of nuclear waste. It's a really simple place. I'm not trying to discredit it. It is dangerous, but it can be safely disposed of. Okay, so you've got large concrete Pringle cans. You put the nuclear waste inside of them. Now, you could hit these things with a train. You could hit these things with a rocket. I did an MIT research project on not actually hitting it with a rocket, but assuming I could hit it with a rocket. My fellow nuclear students were not amused. I thought it was interesting. All that is to say, these are very safe. Now, you may be wondering, then why do we need another solution? We have this great option. Well, keeping nuclear waste on the surface isn't always considered the best idea. Back in the 1950s, we pretty early on realized, oh, we should probably put this deep underground, deep geologic repositories. You've probably heard the words before, Yucca Mountain. The Nevadans just hissed somewhere. The important thing for us to remember about Yucca Mountain is that it was a politically decided location that we then studied a lot on how to safely dispose of nuclear waste in this politically decided upon location. Instead, and modern startups like mine at Deep Isolation and others are trying to use an idea called consent-based siting. Per Peterson, the great Per Peterson, who is on here with us, was part of a thing called the Blue Ribbon Commission, which was a great way of saying, Yucca isn't quite working. What could we do that could be better? Welcome to innovation through and through. It's sometimes politically inspired. It's not always technically inspired. Sometimes it's politically inspired. And so with the idea of consent-based siting, AKA let's make sure that the communities who manage and dispose of nuclear waste are compensated and respected for the decision that they're making, and make this decision on their own volition and with their own power. This is something that my organization is very interested in. Deep isolation, it literally doesn't take 5 minutes. It takes like 1 minute to describe. So you've all heard of horizontal drill holes. If you haven't in Berk, I'm actually very surprised. Horizontal drill holes are what traditionally are used for example, fracking. We do not frack, but the same technology of going down and then sideways is pretty revolutionary when it comes to nuclear waste. It's been well described through a variety of studies now that it keeps nuclear waste from getting to the surface because you don't have a direct path of just a straight line down, and you have literally tons and tons of rock above this nuclear waste. So you can imagine that it keeps it super safe. This super safety is not because we think nuclear waste necessarily isn't a resource. Many people you're probably about to hear throughout the presentation could show that nuclear waste could be used as a fuel. So there's another innovation, right? But even if we want that fuel in the future to be used for the waste to be used for fuel, it's always best to keep it safe as long as we can. And that's where a company like Deep Isolation comes into play. We recognize the risk, we communicate these risks and the rewards of managing nuclear waste in a safe and secure way, and hopefully allow a future nuclear industry to thrive because we are actually managing the waste in the first place. It is never okay for an industry to assume a solution that isn't a reality. It is important for us to clarify and consider the risks that we are taking and how we can actually make them reduced. We will never get them to zero, but we can do better. As Melania says, right? Be better. This is, I guess, I never thought I would end a presentation with a speech by Melania, but I'm gonna actually end there. I think I've described your technology. I think I've described nuclear waste, and I look forward to your questions. Thanks, y'all.
Thank you so much, Sam. And I forgot to open with I use she, her pronouns. And I already didn't write down who was next. I got my pen after.
I think I was next, Rachel.
Okay, Lenka is next.
Great. Hello, everyone. I have a couple of slides to share. So while I bring that up, I'll introduce myself first of all. My name is Lenka Kollar, and I go by she, her. And I got into nuclear because I studied nuclear engineering at Purdue University, and I was really enamored by the technology because it could be used for so many different things. Beyond just nuclear energy, we'll need it to explore space, and today there's medical applications, agriculture applications. So I was really enamored by the technology. But throughout my studies and my career, I learned that we can be very good at the technical innovation side, but if we don't also spend time on innovating on business models and the way we communicate with communities and the way we have policies that enable nuclear energy, then we can fall behind the technical innovation that we have. So I eventually got an MBA, and now I'm the co-founder of Helixos, which is a consulting company focusing on clean energy and clean tech, and we align all of our projects with the UN Sustainable Development Goals. And I wanted to start with, first of all, did my slides come up? Thank you. So I wanted to start with looking at the big picture and what we might see with federal policy in clean energy for the next 4 years. The Biden Clean Energy Revolution and Environmental Justice Plan calls for 100% clean energy, which does include nuclear energy, and specifically also calls out small modular nuclear reactors, which is an area I used to work in before starting Helixos. I was working with NuScale Power, which is a company based in Oregon that's developing SMRs in the US, and recently got its design certification approved for the SMR. So it might be one of the first SMRs that's commercialized in the US, which is really exciting. The plan also calls for carbon-free hydrogen and decarbonizing industrial heat, which Rachel had already mentioned. And what I really like about this plan is that it specifically calls out community-driven approaches, and that's to develop solutions for environmental injustices that have affected communities of color, low income, and indigenous communities. And this is an area where we have to be careful that in the clean energy revolution, we don't leave people out, that we include everyone in it and that everyone can benefit from it. Zooming in a little bit, we can see that there's quite a few states in the last few years that have set their own clean energy renewable goals and standards. And some of those do include nuclear if they're overall carbon-free standards, some of them don't. So this is an area we want to focus on more, as well as making sure these state-level policies are inclusive of all carbon-free technologies. Zooming in a little bit further, there are 30 large utilities in the US that have already made commitments to lower their emissions by 80% or more. And this is quite a wide coverage across the US, not to mention all of the cities and smaller communities that have made some sort of clean energy or renewable targets. So from all this data, you can see that even without federal policy, most Americans live in an area that has made some sort of clean energy goal. And we need to take a look at those and make sure, again, that they are technology inclusive. So what does a community-centered system approach to decarbonization look like? This is the way I see it. So first of all, we have the electricity grid that feeds into both residential and the industrial sector. And that grid should be powered by renewables like solar, wind, geothermal, and hydro. And of course, then we also need battery storage to be able to store electricity when there's excess production and then put it back on the grid when it's needed. We usually have thought of as nuclear as a large baseload provider of electricity to the grid, and getting away from that word baseload, what new and advanced reactors provide is the option to have a lot more flexibility, because often in the case of SMR, small modular reactors, they're small and there's multiple of them on a site, so they can be used to do different things. So that would include providing electricity to the grid, as well as modules could be used to directly provide electricity and heat, especially that hard to decarbonize industrial heat, to the industrial sector to then produce things like cement, which again utilizes carbon capture, as well as chemical refining and making other metals like steel. Some SMRs could also be used to generate synthetic fuels like hydrogen or ammonia, or synthetic fuels that utilize carbon capture to then further decarbonize the transportation sector, including shipping and personal transportation. And what's important to remember here is we usually think of decarbonization in these very large buckets like industrial, transportation, residential, and forget that there's really people. The people are the center of all of these things, and communities are the center, obviously residential areas, but also people work in industry. And so we can have community and people-driven approaches towards decarbonizing the whole system. And this is what shows how nuclear can play into that. So with that, I'll end and pass on to the next panelist, which I believe is Per.
Thank you. Hello, I'm Per Peterson. Let me go ahead and bring up a couple of slides as well here and share this. Thank you. So I'm Per Peterson, and Denard actually asked me, and that's he, him, she'd asked me to put together a slide to introduce myself. So I've done that briefly here. I've been a professor at UC Berkeley for quite some time in the Department of Nuclear Engineering. I'm also a co-founder and chief nuclear officer for a startup company, Kairos Power. I'm going to be representing or wearing a Kairos Power hat for the second half of this presentation and describing some of the work that's going on there, but then want to step back and discuss more broadly this ecosystem for innovation that's emerged. There is I think Rachel has pointed out, we have over 50 companies working in this area of advanced nuclear. I'm a fellow of the American Nuclear Society, a member of the National Academy of Engineering, and I have worked extensively across all areas of nuclear technology, including safety, security of nuclear materials, and also this fundamental question I think that we're all interested in is how to incentivize innovation within regulated technologies such as nuclear. So for Kairos Power, we start every presentation within the company with the mission statement, which is to enable the world's transition to clean energy with the ultimate goal of dramatically improving people's quality of life while protecting the environment. I think one of the things that's quite impressive about this field is that recognizing what the potential is for fission energy to provide one of the major elements of the solutions we need to decarbonize electrical power supply. What we've seen is just an enormous influx of extraordinarily bright and talented people, particularly young people coming in to work in this field. And you can see that right here in this meeting. I mean, I'm definitely among the older people that are involved here. And so it's really exciting actually to be in a field which is showing such dynamic progress. Kairos Power is focused on a combination of coolant and fuel and high temperature technology, which actually has been worked on extensively in the past. The basic concept utilizes a solid fuel, and this is triso fuel, which is fully ceramic. So you can go to very high temperatures without damage to fuel. This is one of the things that differentiates this class of reactor, is this capability to operate at high temperature while retaining radioactive materials. One does that by using a fluoride salt coolant, which has intrinsic low pressure because it has high chemical stability and a very high boiling temperature, in fact, which in turn means that you do not have sources of stored energy that can pressurize or disperse radioactive materials. And this allows you to work with high temperature systems at low pressure, thin walled, where you can leverage technologies that have been studied also for sodium fast reactors. A quick introduction to Kairos. The company was founded in 2016, opened offices, were headquartered in Alameda, opened offices in 2017. Currently 158 employees, about 90% of them are engineering staff, just extraordinarily talented people that have been coming into this field. We are privately funded. We have some government funded, but dominantly privately funding. And our schedule is driven by the goal of deploying reactors by the early 2030s at cost targets that can be competitive with natural gas. So we also have a licensing office in Charlotte. We've recently opened new facilities also in Albuquerque, New Mexico, where we're deploying larger scale molten salt systems, and I'll describe those briefly here. And because the specific fluoride salt that we're working with is a very specialized lithium beryllium fluoride salt, which has very fantastic heat transport properties and stability, we're partnered with the Materian company, which is helping us to synthesize and stand up supply chain for this particular salt. So this is a diagram that shows the conventional design and plan type of iterative loop that one ends up in conventional nuclear development cycles, because the building and testing has traditionally involved multi-billion-dollar facilities that take a decade to deploy. One of the questions is whether you can do things that are similar to what SpaceX has accomplished and move towards a much more rapid iterative development process where you are proving how things work, because you actually do a design, then you build and test. And from test experience, you do the next iteration of plan, design, build, and test. This approach is one that is being implemented at Kairos, and I'll be able to explain how this works. Primarily, in addition to using modern modeling and simulation tools, the other fundamental thing is to perform experimental work that can retire technology risks. And I think when we come to discuss what are some of the impediments to innovation in the past and how to overcome them, building hardware and testing it is one of the critical ingredients, including working with prototypical materials and building intermediate scale systems. So the engineering test unit, which will be deployed in New Mexico this coming year, will be essentially a half height, half diameter, non-nuclear version of the reactor. And that then enables us to deploy subsequently a test reactor. In parallel, working with the Nuclear Regulatory Commission and licensing. So Kairos has some 9 topical reports already submitted, 4 final safety evaluation reports already back from the Nuclear Regulatory Commission, and retiring regulatory issues in an iterative way is another key part of the strategy. So the basic goal here is to systematically reduce risk over time, and to do it by proving how hardware works in increasingly complex systems. And this is just a schematic showing the process, but it does involve very important components, which are pre-application engagement and submission of construction and operating license applications, non-nuclear testing leading to test reactor deployment, subsequently to full-scale non-nuclear testing, and then to commercial deployment. And the basic ideas behind this sort of strategy is that one can retire risks in ways that make decisions about subsequent steps and investment easier to make. And you saw that in the progression that SpaceX went through from the Falcon 1 technology with their first successful launch in 2008 to the Falcon 9, with reaching the International Space Station in 2012, and then of course capturing over half of the world market share by 2018. So remarkable success, and something that we'd like to replicate also and see this done in advanced nuclear. There's good reasons for us to be pursuing multiple paths in parallel, both because reactors have different applications and also because with more shots on goal, we are more likely to see success emerge in this field of advanced reactor technology. And with that, I'm looking forward to our discussion.
Thank you so much. Those were great introductions from everybody. So I've got a set of pre-seeded questions from Berk, and I'm going to kind of work from them to start out with, and then we'll open it up to audience Q&A. So the first is going to be a bit directed at Per, but I think everyone can comment on this. So it's sort of a two-part question. Why is it so challenging to finance new nuclear power plants in the US? And what are some of the key strategies that some of the reactor companies, yours included, Per, are taking to overcome those challenges?
This is Rachel. This is an excellent question. I think because I've done the calculations. You can build windmills and one can also build nuclear plants. And if you break down the costs and ask how much does it cost to build a nuclear plant per pound of concrete, steel, and copper, and compare that to cost to deploy windmills, there's a factor of 10 difference. So there's something that we've been doing to make nuclear fundamentally much more expensive than it needs to be, particularly when you start to look at the natural resource inputs being so tiny. The question is, what fundamentally would drive it to be so expensive, and can we do things differently in ways that can pull down those costs? And I think that the key thing is that when you place multiple billions of dollars at risk, and it takes 10 years to get an answer as to whether you're going to lose that investment or not, one is inherently risk adverse. And when you're risk adverse, you have to make really conservative decisions because you don't know how things are going to work. And one of the benefits of going to smaller reactors and going to iterative development and testing is that you can actually retire those risks much earlier. And we've seen that demonstrated successfully with what SpaceX has done. If you can generate cost certainty through that type of iterative testing process, so you know for sure what it costs because you've built it and you've tested it and it functioned and it did the things you expected and it did the things that you didn't expect and you fixed the things that you didn't expect, you have a better basis to achieve cost certainty and to hit price targets on a per pound basis that come closer to what we get with the renewable options, which have benefited from the fact that you can build and test iteratively and get in many iterations in the course of even just a decade. Being able to do the same thing with nuclear, I think, is one of the things that has the potential to be transformative. And eliminating the set of really severe accidents that water-cooled reactors can have through making them smaller, implementing passive safety, and ultimately moving away from water as a coolant to other coolants which give you higher intrinsic safety. I think those are key things that will enable us to provide that cost certainty and see that large and subsequent investment.
Thanks, Per. That was super helpful. Sam and Lenka, do you want to add anything?
Lenka might be better at saying this, so I'll prep you because I think it's going to be Lenka will hit it out of the park. It's also about making sure that the public doesn't oppose you. Windmills are really expensive. If the public doesn't want you to build a windmill there, it can literally be impossible, right? Impossibly high cost. I'm sure, like oil and gas pipelines, the costs can get really high if you are have a public opposing you. So I will again turn it over to Lenka, but I would point out that it is not just about iteration, it is about inspiration. It is about inspiring people to be okay with what you are doing and to give them a good, happy feeling so that they want to keep doing more of that work. Sorry, Lenka, if I stole your thunder, because that was totally your answer, but.
No, Sam, that's absolutely right. And what I was going to say really builds on that, in that reducing the cost of the technology development process as well as the cost of the actual project. It has a lot to do with reducing the risk, because when you can reduce risk, and whether that's, that can be technology risk, so as Per said, you would start building things right away so that you can reduce the risk of that technology being more expensive than you thought it was and get better at it. But it's also on the social side in terms of reducing the risk of the public being against you or policies being against you. And once it's seen as a less risky investment, then the clean energy investors that are out there, which is plenty of them, will come. So it's more about reducing that overall project risk and first of a kind technology risk to then reduce the cost.
Okay, I'm going to ask 2 more questions and then I'll start taking the chat questions. So in reverse panelist order, the next one is for Lenka, but then obviously everyone else can chime in. So what do you believe will be the future of nuclear policy in the US, and what do we need to do to support our climate goals?
Mm-hmm. So I discussed in my presentation a little bit about what we can expect in federal policy in the next 4 years and all the state, local, and utility policies that are out there. And there's also federal policies that have been put into place and are being put into place that address specifically innovation in advanced nuclear and allowing those first-of-a-kind projects to come online. And I think the next step that we need to take is to really make sure that nuclear is included in the wider clean energy policies that are being made at the federal level and every level at the local, state, utilities, because these policies need to be technology inclusive. And it's not just about including nuclear, it's about opening up the space so that there can be more continued innovation in other clean tech, because there's plenty of other ideas out there and things that people are working on that they want to see included, they want to be included in mitigating climate change. So it's about opening up those policies that already exist to nuclear. And I think by doing that, you'll also get more bipartisan support, which is key.
Sam or Per, any contributions?
I'm really excited. I don't know if you haven't looked at it yet. Lenka gave you a great hint. Go look at the Biden energy plan, because they have this interesting part called ARPA-C, which when I first read it, I was certain was like a typo, because we knew about ARPA-E and we knew about ARPA-D, and I was like, are they just making up letters now? But it's ARPA for the climate. And if you don't know what ARPA is, you need to know that it is the advanced research projects that are going to actually make us be more innovative, right? They're kind of the most edgy kids in the school, right? They're going to be either great geniuses or they're going to flunk, one of the two. Like it's kind of one of those faces, right? And so that is where I think if we would do more of those types of nuclear policies, if we would do ARPA-C, like climate-based issues, and make sure that nuclear is part of it, then it's not a us or them question. It's a we're gonna get this through together. We're gonna think outside of the box. We could have learned a lot. Deep isolation learned a lot from the oil and gas industry. Like, it's not just because the industry is different from yours doesn't mean that we need to be in opposition.
Yeah, I agree with that. I think the important thing to add is that there's fundamentally strong arguments for public investment to support technology development in the nuclear space. One of the key issues is that there's a lot of things that prevent or disincentivize first movers. One of them is the licensing process, and it's not so much that the licensing process is burdensome, although it can be, but it's also because competitors can free ride on the results of the licensing process quite easily. NuScale did this fantastic job working through the set of questions needed to figure out how to do control rooms and have reasonable control room staffing for multi-module, small modular reactors. And a part of the issue with that is that others can take their success and move forward based on the assumption that you could do something similar to that kind of first mover problem. The way that you solve it is with policy intervention. So things such as cost share, those are effective tools to incentivize the first movers to move forward. And it's really wonderful to have seen this ecosystem of think tanks and such as Third Way, ClearPath, Clean Air Task Force, and others who've really been focusing on this question of what could be policy drivers that could facilitate and enable innovation within this field. And it's been working. It's just remarkable how things are progressing, and the things that are happening right now, particularly within like the Nuclear Regulatory Commission, the ability to license advanced reactors is far easier today than it would have been a decade ago, because of a lot of work that's been done to lay it down a foundation and framework for doing this. It's a very exciting time right now.
Right. And the last one, to help provide some context, Sam, what do we do with our nuclear waste now? So we have the Pringles can, but like what else? And then how does that compare to other parts of the world?
Thanks for the question. And I'm probably going to regret saying that now, because when all of Californians are just like, give us more Pringle cans, it's going to be a problem. So what do we do now? We have a few different options. If you have an operating reactor, they sometimes can go in that water that I said. So that's called a spent fuel pool. If it is enough time, or that pool is full because we have not had an effective nuclear waste policy here in the United States since I've been alive, the point has been that we put them in those dry casts, those concrete Pringle cans. And then if that is too much, right, then we put them in what are called independent spent fuel storage installations, ISFSIs, which is just a terrible acronym, which is a bunch of Pringle cans on a concrete pad. And that is basically the height of innovation when it comes to nuclear waste right now, because nuclear waste law dictates that all nuclear waste must end up in Yucca Mountain in Nevada. As I've said, now both President Obama and President Trump have now come out against Yucca Mountain, so it doesn't seem to be moving forward, and one can expect that. Internationally, nations like Finland and Sweden are building, again, deep geologic repositories, like I said before, getting it deep underground, similar to Yucca Mountain in different types of rock materials is the easiest way to describe it. And then other nations are considering reprocessing. So for groups like France and considerations in Japan are trying to reuse this nuclear waste and turn it back into fuel to get a little bit more juice out of it. That's the current nuclear waste situation.
Great. So our first question was actually sent just to me, so I'm going to ask it. And Bill, if you want to add more, please speak up. But what is the ability of nuclear reactors to provide variable power? And both maybe how do they do that now and how might they do that in the future? Lenka, you alluded to this a little bit, but maybe some more details on that.
Sure, I can start with that. And I will say that advanced reactors are, and the developers are very well aware that they're going to have to work on a grid with renewables. So building the ability to have variable and flexible operations is integral. And there are also standards that EPRI puts in place to which reactors should adhere to. And when I worked for NuScale, I know that the flexible operations from that, there was a study done where a NuScale module could directly load follow with a wind farm, for example, and that's done by building in a turbine bypass, which is simpler to do with a smaller reactor because you also have smaller turbines and you can dump that steam into the condenser and put it back online when it's needed. Now, those of us that are engineers or care about sustainability who don't like the idea of dumping steam, it irks me as well. So what I mentioned in the presentation is where the real opportunity is when you don't need that electricity online because you have a lot of renewables or demand is low at night, for example, you can use that steam and that energy to do other things like produce hydrogen, other synthetic fuels, or even run a desalination plant. So that's where, to me, the real ideal flexibility comes in, is when you can not just be variable on the way you provide electricity to the grid, but also do something else with that energy while you don't need electricity, because reactors are still more efficient and more cost effective when they're being operated close to 100% of the time.
Thank you. I want to say, so I'm Bill Quirk. I'm in the State Assembly. I'm a PhD in astrophysics. I've been following the nuclear industry for longer than any of you have been alive. Coming to the question of waste, the people I worked at Lawrence Lab, I was a nuclear weapons designer. There's a lot more nuclear waste buried at the nuclear test site than at Yucca Mountain, and Yucca Mountain is further from civilization than the nuclear test site is. You're right, the problem isn't that we don't have the technology. The problem is overcoming the resistance of folks, both to nuclear reactors themselves. And I could tell you if I was pro-nuclear, I'd have a hard time getting reelected. So that's part of it, but also to the question of where the waste gets stored. And I'm just wondering what sort of strategies any of the four of you might have to get over the idea of any place in the US actually allowing a nuclear plant to be built and waste to be stored. Because frankly, the way we're doing it now, where it's distributed around the country at all these different plants, some of which are now being decommissioned, is just the worst possible thing you can do. But it's still what we're doing because we can't get any further. So if anyone wants to take on any of those questions, I'd be very pleased.
Yeah, and I'll combine that with the next question that was in the chat, which is how's Kairos planning to work around NIMBY? So I think we can hit those at one time.
That sounds good. Let me start off, because this is a really important question, and I think Michael Schellenberger's position on nuclear waste, that it is the best thing about nuclear power, is that sort of counterintuitive statement that has really fundamental truth to it. The volumes are quite limited, which does make the deep geologic disposal economically practical. And in fact, even though with Yucca Mountain, when we started to discover some of the deficiencies behind the site, such as the rapid fracture flow, and we addressed those deficiencies by adding things like alloy 22 canisters and titanium drip shields, you could still fund that entire disposal of all of that spent fuel with a 0.1 cent per kilowatt hour charge. That's a tenth of a penny per kilowatt hour. And so geologic disposal can both be safe and affordable. The lack of consensus around Yucca Mountain, I think it's important to recognize that a fair amount of the opposition came from people that were opposed to the disposal of the spent fuel because of the arguments about whether it should be recycled in the future, in addition to people who had concerns about safety. I do think that the technologies that, for example, deep isolation are working on not only can achieve significant further cost reduction, but also just have better intrinsic safety. They avoid the need for the construction of deep underground mined facilities, which are expensive to build, and therefore they give you also much greater siting flexibility. The fundamental point is that deep geologic isolation has a strong scientific technological basis for being safe and for providing long-term isolation. And it's something that we can do in the future. So we know that there are viable solutions for disposal of nuclear waste. With respect to what we're doing with fossil fuels and putting carbon dioxide into the atmosphere, there's no scientifically or technically logical approach that we could expect in the future that can ever reverse that. So stopping the burning of fossil fuels is really the most important thing we need to do. And then on NIMBY, it's very interesting the level of local community support that you will find around nuclear power plants in the United States. That support comes from having well-educated people who are familiar with how the plants operate and who are comfortable with it and appreciate both the economic benefits and the zero carbon emissions. I do think that if we address the cost and further improve the safety of these technologies, it's not going to be difficult for us to site future nuclear power plants. As long as we take it as being a fundamental responsibility to protect public health and safety, which we have done and which we continue to do, and which we will do even better in the future. This is something that I think is a solvable problem.
That is a really hard to add anything to that because we're pretty much well clarified that. I'm going to give you a very specific anecdote, Bill, as a person who is, there in Sacramento often and recognizes that, yes, if you came out as pro-nuclear in the California State Assembly, it's not going to go great for you. That is in large part because of this idea, this consistent idea that everyone else thinks that nuclear is bad. It's the idea that I think it's good, but the other people around me don't. And that kind of leads us into this circular system of everyone thinks it's bad. In actuality, you'll see, you know, later on, these nuclear bills that are passing through Congress are passing nearly unanimously, with Democrats and Republicans voting for them, because the innovations around them don't know a political party. The easy anecdote that I kind of like to use about this is music choice. I'm a huge fan of High School Musical. Now, that's super embarrassing to a lot of people. They're like, oh my God, no one likes High School Musical, but I really do. But I don't have to be ashamed of that, because I know that I can like this kind of music, and you don't have to like it. But the problem is going to be is that, will I not tell other people, and will I not give space for conversation around the power of High School Musical? Or will I just silence myself and thus silence the potential for another person to find music that they may love? This is kind of where it comes to with nuclear waste, is that we think that everyone is super opposed to nuclear because of nuclear waste, but there are a lot of solutions out there, right? Like, I work for a nuclear waste company that has more than 10 sites that are interested. It's not NIMBY, it's PIMBY, it's please in my backyard. So how do we get those stories to be raised at the right time? Because we've learned this. Every single time a community tries to step forward, they are immediately shamed and ostracized as not having all the information. No one could possibly want this. To be very frank, Nye County, where Yucca Mountain is a super fan of having it there. It's just the locals of, as you know, right, Las Vegas, who maybe don't necessarily want to have nuclear waste nearby. So I get it, Bill. I think it's really important for us to recognize that it's not easy to come out, right, for nuclear solutions, but it is the most easy bipartisan issue that I have found in Congress, and that's saying something.
So I'm gonna ask this next question, which I think we can answer quite briefly. So the question of, are we doing enough to fund fusion R&D? I feel like we haven't given enough background to discuss that very well. Does anyone want to chime in on fusion R&D funding?
Let me just say that it's important for us to be working on these longer term options. And furthermore, a lot of the problems that you try to solve for fusion, they're challenging, but they feed back to providing solutions to things which are also nearer term. So I'm a strong supporter of those kinds of public sector investments. And I do think that there's real value in pursuing these longer term energy options, including fusion.
Yeah, I agree with that as well, everything that Per said, and would add that there's surprisingly quite a bit of private investment going into fusion companies, because they see it as the energy utopia if we can achieve it. So that, I think that's been quite interesting to see, that influx of private capital going into fusion projects, which may be more beneficial than public funding sometimes. But of course, usually a mix of both is needed to get where we want to go. To answer the question whether there's enough, you can always have more, probably.
So the next one, Kennedy, I might need more clarification on your question. Are researchers and policymakers looking at public banking initiatives as a way to tie in future and new age nuclear projects? I don't know if I'm.
Which banking initiatives?
So it's public banking. Is that like?
I just helped with the bill on that. Public banking means a bank that's owned by a state or a government. And there is, I think it's Montana, has a state bank which invests locally in the state. You're allowed, if you're a local government, to do that in California, but the regulations are quite strong, so no one's done it yet. But I only know of one public bank in the country.
I think that's a fantastic idea. Yeah.
Yeah, if I could clarify the question actually too. The reason I asked is because there are public banking initiatives happening, and I'm wondering if some of the projects with the SMRs happening, like, are there ways that we could tie in those conversations with those communities as ways to uplift their communities and out in the outlook? If there are projects happening there, it might also help with those initiatives. That's why I asked.
I'd flag that as an important potential opportunity and follow up on it. I can't answer any more than that, but it's actually exciting to see some of these ideas emerging out of the conversation we're having here.
Yeah, I just wrote that down. I'm going to look more into it. Cool.
I would say on public banking, I know there's a few green banks that have started, and I'm not sure if they're exactly publicly funded, but there's a Connecticut Green Bank, for example, and they generally don't include any investment in nuclear projects. So again, this goes back to making sure that all of those local, the state, the utility, the banking policies are inclusive of all clean energy technology. And there's green bonds as well. There's clean energy certificates. There's all kinds of mechanisms that are allowing renewables to excel in the US environment and opening up those methods, whether it's on the public side or the private side of green investments, to also include nuclear is very important. And the way I picture that as well, it's not about taking a piece of the pie from renewables to allocate to nuclear. What happens is you bring new types of investors in once you open that pie to nuclear and other technologies. And so you're actually expanding the pie for more investment to come in rather than taking a piece of it for renewables. So that's the way I see it, as expanding the pie rather than taking it away.
Yeah, great distinction. Thanks for that question. Okay, what is the comparative total end-to-end cost and risk of waste management?
Let me take that one up, because I had just mentioned in the United States, in part because it is a pretty large inventory. Well, 70,000 metric tons is actually, if you compare it to the amount of waste you'd have got from burning coal, it's minuscule. It's a factor of 1,000,000 times smaller. But the 0.1 cent per kilowatt hour is sufficient to fully fund the geologic disposal. That's sort of the price range. And 0.1 cent per kilowatt hour, if you look at it and compare it to the external costs of fossil fuels, it's 1 to 2 orders of magnitude lower cost than the non-internalized costs that we are accruing because of our use of fossil fuels. And so even if, let's say, it was 0.2 cents instead of 0.1 cents, that increment in the external cost is still so tiny that our decisions to use nuclear energy are highly appropriate. And this goes back, it's such a tiny volume of material that you need to manage. It is practical to use the deep geologic disposal methods. But today we actually, I'll tell you, we don't know for sure whether spent fuel is a waste. Nobody can know today, because it certainly is from the perspective of existing reactor technologies, but that evolution in reactor technologies is likely to make potential recycle of at least some of the spent fuel economically attractive in the longer term. Regardless, there are going to be residues, or there will be spent fuel that will require geologic disposal. And we should be moving forward to develop those capabilities and deploy them in the United States, so that we can address with confidence that it is feasible to place these materials into deep geologic disposal.
Well said. The addition is that instead of doubling it, with innovations like my company, you can more than halve it. So instead of it even being a penny, it's half a penny. So what is the total cost? The total cost is going down by the decade, I would say. And especially if you see nuclear waste as a potential fuel in the future, it could be, you could have a negative cost. But I would argue that even with, nuclear waste as a fuel, you will always have some remnant which needs to be disposed of. And it is always appropriate to dispose and to take care of the environment with which you've created. So I would say that there will always be some cost. That cost can be surmounted with, a variety of different spaces, but the risk and the costs are decreasing as we innovate in this field. Specifically, like I said, with deep isolation, we're so much below Yucca Mountain cost because we're not putting humans underground. It's amazing what we've learned as a nation and as a globe of when you don't need a human to do everything, you have a significant cost reduction. And this isn't necessarily losing jobs. This is saving money on waste.
Let me add one additional really interesting thing. The decision to stop the work on Yucca Mountain also meant that we stopped appropriating money out of the nuclear waste fund. It's been gathering interest ever since. There's $40 billion in the nuclear waste fund at this point in time, and it's accumulating interest at $1.5 billion per year, which is actually more than double the maximum rate at which fees were being charged with that 0.1 cents per kilowatt hour. The courts have become so upset with the federal government that they've actually directed DOE to stop collecting the fee. It's my expectation that if we can implement cost-effective solutions such as borehole disposal that are safe and affordable and flexible in siting, DOE will never need to restart collecting the fee. That is just the revenues on the existing monies that ratepayers paid into the nuclear waste fund over several decades is more than sufficient to fund all US nuclear waste management going forward in perpetuity with zero fee. And wouldn't that be counterintuitive that nuclear waste is free because it's so affordable to manage, and we've already funded all of that work with these previous rates. It's quite exciting that we could flip entirely on its head the way people would think about nuclear waste because of the fact that we actually have this tremendous fund that's built up, and we have these emerging new technologies that can provide very safe and effective, cost-effective disposal. It's neat.
Okay, I'm gonna ask the next one down, and then I'm gonna skip to one because I want to ask it, and I haven't read them all, but we're running out of time. So this is from Dylan. Sam, political question. The prospect of a Republican-led US Senate brings up general questions about how much President-elect Biden can do. Nuclear energy, however, goes down easier with Republicans and is gaining traction among Democrats. How does the 2021 Republican Senate feel about the Biden climate plan and its nuclear contents?
I love a political question. Oh, so great. So my Senate contacts have been pretty clear. If nuclear waste is not part of the climate solution in a Biden administration, there will not be much of a climate solution in a Biden administration. So I expect there to be strong support for that. This is an election and a Senate who are going to hold things very much to the center. The great thing is that, as I mentioned earlier, Nuclear Energy Innovation Capabilities Act, Nuclear Energy Innovation Modernization Act are strongly bipartisan bills. These are multiple presidential candidates on the Democratic side ran as co-authors of these bills. So I think we are going to see a strong support of nuclear innovation. We need to make sure there's still a strong support for the currently operating fleet to make sure that we're not, as Per was mentioning, not putting more carbon emissions into the air. And we need to be thinking, I really hope, I say this every administration, and I've been let down every single time. Maybe we will have a nuclear waste bill. Maybe we will finally have some, breakthrough that would allow us to better manage nuclear waste when it comes to policy. All of these are possible with a Republican Senate and a Biden administration who has already, again, openly, as Lenka mentioned, openly said support for nuclear energy and innovation around nuclear energy as well.
Okay, the one I want to not skip. Are there creative art-related projects being organized to reimagine nuclear to the public?
Yes.
And I'll finish
There's
it.
definitely project. Go ahead. Sorry.
Oh, the other half is that Solar Punk, which is one I haven't heard of, is a literary fiction gaining traction. I have heard of Solar Punk, obviously. Anyway, go ahead.
Oh, There are some projects. There's a project called Reimagining Nuclear. Google that and you can look it up. That's, you know, in that name. And there's plenty of us that have lots of ideas in this space as to how we can rebrand nuclear and, you know, make it something that's cool, make it something that people aren't afraid to talk about, or because they think everyone else is against nuclear. However, and the industry very much recognizes that communication is important, but I don't think enough money is being put into this specific aspect. And you can't just expect people to develop this content for free. Things take time and people, and there's great people out there that could do this type of work, but there's not, I think, not a strong enough sense for actually funding it and making sure that, you know, it's done in a way that is inclusive of everyone. So I think there's a lot of opportunity in that. And we also, I would encourage, you know, if people are interested in this, to look up what's already happening out there and take some time to look into it and develop your own things if you want. But to really make it professional, to really make it reach a lot of people, there needs to be some resources put into it.
Really well said, Lenka. I think for me, the art interesting space has kind of been on cinema and movies. So we've had great shows like Madam Secretary address nuclear energy, but then we've also had things like Chernobyl, right? So there are a variety of different ways that people are approaching nuclear in cinematic ways. I think getting an actual like group of artists and otherwise to listen. So I get to advise for TV shows pretty often. It's a pretty awesome job that you get to like tell people how things work and then they do these things. Now, I did not advise on some of these nuclear shows and then I yell at them, why didn't you ask us, right? So, but the problem isn't that they didn't ask us, it's that they didn't know to ask. So I think there is something to be said for the nuclear industry, as Lenka mentioned earlier, right? Like kind of being a resource for Hollywood. We're not going to change art and cinema without being the person who's willing to like raise their hand and say, I'll try to not come in with a bias of just build more nuclear. I'll come in with this is not how a nuclear bomb would actually be diffused. Will you please stop saying that you just cut a cord, right? Like these are the things that I think would be very helpful to make art a little bit more, I'm not gonna say nuclear friendly, but nuclear realistic.
I just add that aesthetics are important, and moreover, the things that you do to design facilities and infrastructure so that they can function very reliably, and so that you can keep everything clean and you can provide a safe work environment, intrinsically can have good aesthetics as well. And it's worthwhile for us to focus on doing that. In addition to, I think it's a fundamental part of being a clean energy technology.
So I've heard really great comments from all of you. We have 2 minutes left. So Dinara, I wanted to ask, do you want to ask the last question, or should I give every speaker, you know, like 30 seconds to say?
Yeah, I think we can ask one more question. That's okay. And then, yeah.
Okay. So what advice can the panel offer to change policy? This says in Australia, but there are a number of places where this is true, where nuclear is currently banned.
If there's anything I've learned.
The question is,
go,
go,
Lenka. You are way more qualified.
Well, the question is from Tony Irwin in Australia, and I've talked with Tony at length about this. I'm currently now in Australia after spending the last few years in DC, and changing a ban is going to be difficult. It's going to take time. It's going to take building trust, and it's going to take having a community that does want it in their backyard. And Australia has some history in this, in the nuclear waste front. Having a proposal for South Australia to be an international host for spent fuel disposal or storage facility. So there's some history in trying to get this community support here. And since I've already talked to Tony at length about this, I want to hear from the rest of the panelists too as to what they think about, you know, how do we build that support?
The one thing that is critical is to stand up competent nuclear regulatory safety authority. Australia actually already does have that. Australia has a fantastic research reactor and that does isotope production and other important missions. Building trust and confidence in this technology is something that takes time, and it's also something that's easily lost quickly. I think, Lenka, you're correct. This is a long-term effort to build that kind of support. But it's worth doing. We need to save the climate, and Australia mines a lot of coal, so it has more than its fair share of the responsibility for what's happened to atmospheric CO2 concentration.
I have learned long ago to let brilliant women say brilliant things. Lenka basically stole everything I was going to say, so I will let Lenka's words stand. Per, you are also brilliant. Did not mean to say that you weren't, just meaning Lenka, you did spectacular there.
Well, we are at time, y'all. Thank you so much for your time and attention, and thank you so much. This is a fantastic panel. It was an honor to moderate for you all. And I so appreciate your perspectives and insights.
Thank you. Big thank you to Berk also. This is a really important convening of experts across a wide range of different technical questions related to energy. And it's always, really exciting to learn what's happening and see all these upcoming and new opportunities. Thank you so much.
Berk, thank you for hosting Nuclear, and everybody go to the Berk Summit.